is to get out your notes. Because we are going to start our study of polar coordinates. So we are on the back of page 51, the back of page 51 of your notes. You'll leave one, but you think that was good. All right. Here we go. We're on the back of page 51, and we're on section 6.4. Now, a little background to get us started. Jalen Buford. A little background to get us started. Your whole life, Kennedy, I don't know what's in your ears, but get it out. Our whole lives as math students, every time we have been asked to graph something, you have done it on a grid graph paper that looks like this. So if you were asked to plot the point 2, 4, you counted over 2 and up 4, right? And that's how you plotted your point. This is called a rectangular system. And the reason that it's called rectangular is, as you go to plot your points, you're moving rectangularly. You're moving horizontally and vertically. The graph paper itself is just a bunch of little rectangles, right? Now, I said this morning, and somebody said, no, they're squares. Squares are rectangles. This is just a bunch of little rectangles. Sometimes this system, where ordered pairs are x, y, this system is called Cartesian. So you'll hear both words. You'll hear rectangular and Cartesian, and they both mean your ordered pairs are x, y. And that's how it's been your whole life till today. This is a big day because now we're going to look at a system of graphing that is not rectangular. Now, today we're not plotting any points. I gave you graph paper yesterday, remember? And it had this on it. Our points now are going to be identified as r, theta, where r is the radius. So you're going to count out 1, 2, 3, 4, 5, however many circles out you're going. That's what this is, the distance from the center. How far out do I go? What's my radius? And then theta is what we have been calling the direction angle for the vector. So when we start plotting, and we're not doing that today, but when we start plotting points tomorrow, probably, or whenever I see you again, we will have to keep in mind that r is how many circles out we count, and theta is the direction angle. So when you look at your notes, again, we're on the back side of 51, 6.4, 1a. It says I have, oh, by the way, this is called a polar system. These are polar coordinates. These are rectangular or Cartesian. These are polar, like the North Pole, polar. So we have a polar coordinate pair. This is r, this is theta, and it says convert it to a rectangular pair. So convert it to x and y. Now I want you to think about the quests that you took yesterday. By the way, those are graded and the scores are in. I just came from a meeting where I was told that the students reported that no, not you in particular, but just students reported that no teachers keep their grades updated.
They don't.
That's facts.
That makes me angry.
It makes
This
us
is for you're always on top of it.
I don't want to hear no teachers, because I work really hard to keep mine updated.
Okay, well, you are a teacher,
You're
and
like
your
the
peers
outlier.
don't do their job.
Okay, but that's not what was said. What was said was no teachers, and I don't
Okay,
think
well,
that's
9
fair.
out of 10 teachers.
Well, maybe
don't
9 out of
pick
10.
the
I
right
hope
thing.
that's not the case. But to say no is, that's like me saying that, you know, all kids are, yeah, something. And that you, some maybe are, but not all. So be careful.
They put in zeros, but when you actually turn your stuff in, they don't grade it. They take don't grade it. So they put in zeros quick, but they won't grade your work.
Okay. Well, I put in zeros too. So some of you have zeros.
I know, we got you put money real quick.
I know, and when you take it, the zero will come out.
Most of things will put down zeros.
Here's my philosophy on that. Apparently some kid was complaining, and I don't know how many it was, 1, 2, 50, I have no idea. Complaining that at the end of the quarter, so you go along all quarter and you have, I don't know, an A, okay? And then all of a sudden in the last couple of days of the quarter, you end up with a C or a D or something. So here's my philosophy on that. If you don't take something, I'm gonna put in a 0. Because what happens when you take it is, your grade can only go one way. As soon as you take it, your grade's gonna go up. If I leave that blank, and you don't take it until whenever, unless you do really well, when I put that grade in, your grade's gonna go down. So my philosophy is, I'd rather have you think you have a lower grade than you have, and then when you take it, your grade goes up, rather than vice versa. You can agree or disagree with me, but that's the way I do it. And you know that I'm not always the next day with makeup work, but within a couple of days, your grade is in there after you take it.
You're an extreme outlier.
Huh?
You're an extreme outlier. Most teachers
I've been
will put
called
in
an
zeros and
outlier
not the
many
real
times.
grade.
Not necessarily a good thing, but that's all right. It is what
It's a
it is.
good thing in this case.
In this case, it's a good thing. Okay, now, we are gonna take this ordered pair, which is a polar coordinate, and we're gonna change it into a rectangular. The quest you took yesterday, you did that, because there was a question that said something like, this is 15 and this is 32 degrees. Find the components of that vector. Now, what were we talking about when we said components?
X and Y.
Finding X and Y. What are you doing in this problem? You're finding X and Y. Now, do you remember how you found X and Y from this yesterday? Sine and cosine. And didn't you end up saying on this problem, X equals 15 cosine 32 and Y equals 15 sine 32? Isn't that what you ultimately typed into your calculator?
Yes.
Kids, that is the foundation of this whole exercise. X always equals R cosine theta and Y equals R sine theta. Always, always, always. So if you have an R and you have a theta, then all you have to do is plug and chug. X will be R cosine, Y will be R sine. Now, if it's easier for you to change that into degrees, you can do that. You don't have to, but then you're going to have to be changing your calculator back and forth between modes. Plus, the graph paper I gave you yesterday is in degrees. And so we probably at least better review how to change this into degrees. That's a radian measure, which is fine, but how do we change it to degrees? Do you remember?
180.
Pi is 180, divided by 3 is 60, times 2 is 120. So this is the point 2 comma 120. So what's X? X is 2 cosine 120. What's Y? 2 sine 120. I type those into my calculator. I don't have to change any signs. I don't have to worry about anything. Whatever it says is the answer. So I think X is -1. and y 1 point, what's the sign? 1.73. And that's it. That's all there is to it. So let's look at the next one. We're doing exactly the same thing. It says find the rectangular coordinates for -3, 135. Now, kids, that means you're going to find x and y, right? So if we're finding x and y, this must be r and theta, which kind of makes sense because that's an angle, right? So what's x? -3 cosine 135. Right here, kids. Gotta know it, gotta know it, gotta know it. But oh, by the way, you memorized this a long time ago, but when you memorized it, it was cosine equals x over r. That's what you memorized off that sheet I gave you of trig stuff to know. This is the same equation with the r brought over. Same thing. And then y will be -3 sine 135, so I need somebody to type these in for me. X is going to be something. What is it? 2.12, and then y will be -2.12. Probably. Boy, this is pretty easy. What about 1,317? What is that going to be in terms of rectangular coordinates? X is going to equal what? 1 cosine 317, and y is 1 sine 317. Oh my gosh, this is so easy. So type it in on our calculator. Mason's going to get his out for us. Armand's already doing it. What'd you get? It's going to be a small number, Armand. 0.73. And then 0.68. I did ask him, but someone else answered. He wasn't paying attention, so it was okay. We got it. All right, one more. Let's give it a shot. The last one in this section. What about 4 5 pi over 6? Now, I want to be clear. You can leave that angle in radians. But if you're going to type it into your calculator, then you got to make sure that you change it to radians and then change it back to degrees for the next problem. So I'd rather just change that 5 pi over 6.
150.
Right, so pi is 180 divided by 6 is 30 times 5 is 150. So our point is 4 comma 150. Does everybody remember doing that before? A long time ago, but yeah, we did it. I remember it. So x equals 4 cosine and y equals 4 sine. So we should have our coordinates then. What's our x? 3.46. Should be negative. Okay, negative 3.46. And I bet that one's positive too, isn't it? How do you know that? Because I know the sine of 150 is 1/2.
How do you know the sine of 150?
Because the reference angle is 30, and in a 30, 60, 90, the opposite side's 1, and the hypotenuse is 2. You know all that too, you just forgot. 30, 60, 90. 150 has a reference angle of 30.
Oh, that's, you're calling that the reference. Oh, okay. I was confused.
So you could do all that too. You probably might have to write it down.
I've always just called that angle a supplementary angle.
It is a supplementary.
What?
Okay, now we're going to go the other direction. So this is not hard, especially since you've already practiced it with your vectors. But it is not quite as easy. Okay? So now we have the polar pair r theta. Zion? We have the polar coordinate pair, or no, we have the rectangular coordinate pair, xy, and we're changing that into r theta. All right, so I want you to think about this for a minute. This is not quite as easy. It's a little bit harder. But if you think about what 1, 2 looks like, would you agree that that's the triangle that would generate 1, 2? If I put that on a circular system, isn't this r? So r is the same as the hypotenuse, or what we called in the last little unit, magnitude. R is magnitude. R is going to be found by doing what? Square it, add them up and take the square root. So your R coordinate is just root 5. You can think of it as the Pythagorean theorem. You can think about it as magnitude. I don't care. It's root 5. 1 squared plus 2 squared. Now, this is theta. In the last little unit, we called that the direction angle, right? How did we find it on the quest you just took yesterday? What? Tangent. We said the tangent of that angle is 2/1. And then we went to our calculator and second tangented. And we got 63. Now, on some of your problems, you got 63, but 63 wasn't the answer. Remember? Because you had to make some adjustments. But in this case, 63 is the answer. So your answer is root 5, comma, 63.43 degrees. That is the polar coordinate pair that corresponds to 1, 2. Now, the vocabulary is different, the directions are different, but the math is exactly what you did on your quest. You found the magnitude and the direction angle. Look at the next one. Same exact thing. You have -3, 2. That's your x and your y. And you're changing it into r and theta. How do I know I'm changing it into r and theta? Because the directions say find polar. All right, so let's draw a picture. All right, somebody already figured out r. R is root 13. Are you okay with that? R is the same as magnitude. This is r. You don't have to draw it, but envision a big circle. That's r. Radius. Now, I gotta find this angle right here. How am I going to find that angle? I know that the tangent of that angle is 2/-3. So second tangent,
Y'all lost me.
I got 33.69. Now, I called it theta, but is that really my direction angle? The direction angle is what goes here. Is 33 the direction angle? No. The direction angle is this one, just like it was yesterday. That hasn't changed. So how am I going to find the actual direction angle? Doesn't have anything to do with 90. 180 minus. 180 minus. This is 90 for sure. But do I know how big that is? No. So let's do 180 minus 33. So 180 minus 33 would be 146.31. And that is your answer. Oh, we may get to pot today after all. I didn't know we'd get there, but we're gonna get there, I think. Okay, here we go. -3, -1.
Wait, so that's for
What? So Joe has already said that the radius is √10. How do we find the radius?
Magnitude.
And how do we find magnitude?
Square plus square.
Square plus square,
Take the
square root. That's right. So 9 plus 1, √10. Perfect. Now, I gotta find that direction angle. So this time my picture looks like this. And somehow I gotta find this angle right here.
Second tangent.
So second tangent, I should come up with a new letter for that angle. I'll call it, hate to call it X, I'll call it A. So what about that? The tangent of that angle is -1 over -3. Is that right?
Yes.
So I'm gonna second tangent it and get 18.43. So that angle is 18.43. So Malcolm, do you have any idea what my actual theta is going to be? Because I figured out that this one is 18.43. And you figure out the actual angle you want is this big one here. You know this. I know you know this. Look up here. How far is it from here to here? Okay, and I'm going 18 past? So how would I find out the whole thing? Huh? Add 'em. Wouldn't I add 'em? So it'd be 198.43. Judith, your hand up. Are you in degrees? Are you typing second tangent?
I want to take a second.
That's how we find angles, Judith. Second tangent or second something, always. Okay, one more. Same thing. We're going from rectangular to -4 to polar. All right, so here we go. Somebody has already figured out that my R is 2√5. How did we get that? It's magnitude. So we squared this, added them together, we got 20, and the square root of 20 is 2√5. Now I need this angle right here. I don't care what you call it anything you want. If I want to find that angle, I know that its tangent is -4/2. So how will I find it? Second tangent, basically -2. Oh. 63.43. Now, if you put that in the answer blank, you're not going to get full credit. Because the full credit angle is this one. That is your direction angle. That's your theta. So let's look at that. How are we going to figure it out this time? Subtract from what? Okay, now 270 is right here. That has anything to do with that 63. That 63 is over here with the 360. So it's 360 minus 63, right? So 360 minus 63 would be 296.57. And that's it. All right, so now we are going to do a little bit of graphing. This is fun. This will be fun. You'll enjoy this. So I'm going to set up my grid real quick. All right, so here we go. First point we're going to plot in problem number 3 is 2, 15. Now, the 2 stands for what? The 2 stands for the radius, right? So we're going to be out here on this circle right here. This is going to be the circle we're on. That's the second circle out. Now, where are we going to be on that circle? On the 15-degree line, right? And this is the 15-degree line? Emma? Okay, it's an emergency. So 2, 15 is right there, right? So we're going to plot the point 2, 15. Everybody okay? And I'm going to label that point A, because on your test or quest, you'll have to plot some points and you'll need to label them for me so I know which one's which. So I'll call that point A. All right, B is 3 pi over 2. Now wait a minute. What's pi over 2? 90? How do we know it's 90? Because pi is 180. So this is a 90. So where is that one going to go? On the third circle out and straight up at 90. So there's point B. Remember, the first number tells you which circle to get on, what radius. The second number tells you which line to get on. 5 to 10. Let's see, this is 180, this is 195, so here's the 210 line. And I'm all the way out, should be the last one, I think. I think your circles only have 5. And then we have 4, 5 pi over 6. What's 5 pi over 6? 150. And let's go through how we got that again. Pi is 180. Divided by 6 is 30. Times 5 is 150. So your 150 line is marked over here. And you're on the 4th circle out. So that should be D. Everybody good with that? That is pretty easy, isn't it? All right, now it's all going to get messy. Look at number 4 and tell me what is different. There are negatives on that first number. Now, wait a minute. What did Mrs. Ford just tell you about that first number? What's that first number supposed to be? The circle you get on. How in the heck can we get on a negative circle?
Go down.
No. Although that's how we do negative angles. So if any of the angles are negative, that's how we would do it. It's wild and crazy. Let me tell you how it works. We're going to do -1, 30. When the radius is negative, it tells you you still get on the one circle. You still get on the first circle out. But instead of going on the 30 angle, you go on the opposite angle of 30. So if this is 30, the opposite angle would be down here. Would you agree? Like, if I said, let's go the opposite of north. This is north. What would the opposite of north be? South, right? So if I'm over here, the opposite would be over here. How many degrees different are opposite? 180. It's like the opposite side of the circle, 180 degrees. So instead of plotting this on 30, it's going to get plotted on 210. So you're going to plot that point over here. It's still on the first circle. That doesn't change. But the negative tells you to plot it on the opposite side of the first circle. So instead of plotting it at 30, we're plotting it 180 degrees different, which would be 210. Crazy. Oh, I guess that's not A, that's E. So that's crazy. So let's try the next one.
270.
Okay, now, the next one is tricky because the R is not negative. The R is not negative. So I'm on the circle with a radius of 2, so I'm on this circle. Where would negative 45 degrees be? This is what you were talking about. You gotta go down. So this would be negative 15, negative 30, negative 45. So negative angles just go down, like they always have. Negative angles go down. Negative R's go to the opposite side. So this is a negative angle. So it is plotted right here on the 45, negative 45 line, 2 circles out. So that is point F. 2 circles out, negative 45. Positive angles go this way, negative angles go this way. So that's where F is plotted. Now G has a negative R. Now wait a minute, a negative R. I'm still going to be on my third circle. I'm still going to go on my third circle. But instead of graphing it on 90, I'm going to graph it on the opposite, which will be 270. So here is point B. This negative takes you to the opposite side of the circle. A negative R takes you to the opposite side of the circle. I know what some of you are thinking. You're thinking, oh my gosh, Jalen. Some of you are thinking, why in the world do we even have negative R's? They happen when we graph some curves, which we're going to do as soon as we plot one more point. So one more point, here we go, negative 5 comma pi. Negative 5 comma pi. Pi is the same as 180. Where's that going to be plotted? 5 comma 0, that's exactly right. Right here's point H. Now, did anybody think 5 comma 360? That would be okay. Isn't that the same spot? 0 and 360, aren't they the same? 180's over here. The opposite point would be over here. Well, we're all bored out of our minds, but now we're going to have some fun. Get your calculators out.
What happens if both are negative?
Then you go to the negative angle and then go to the opposite. So if it was negative 2, negative 30. Negative 30 would be down here. I need 180 degrees difference, so it's going to be plotted at 150. Positive 2, 150.
Okay.
It's 180 degrees difference
Okay.
from the negative angle. Okay. Now we're going to sketch on our calculators. In the old days we had to do this by hand, but you don't have to because you have your calculator. we are going to sketch a polar equation. And you are going to really enjoy this. Okay? But I need everybody looking at a calculator. And here's what I need everybody doing. Is everybody paying attention? It's good stuff. You're going to enjoy it. Go to mode. And you remember the other day we went to PAR so that we could graph parametrically? Right next to PAR, you see POL, which is polar. So now we're going to highlight polar. Okay? Now we're going to go to our window. And I need everybody's window set up like mine so that we're all looking at the same picture. Okay? Theta min, 0. Theta max, 360. Theta step, 5. X min, -5. X max, 5. Y min, -5. Y max, 5. No. Now, I want you to go to y equals, and it says r equals right on the screen, and I want you to type in this equation. So you're going to type 2 cosine 3 theta. And theta is your variable button. The same place you used to get x or t, now you get theta.
Right before the y minimum is x SCL.
X, the scales don't matter, scheme is 1. Okay? Now press graph. And you should have gotten a picture that looked like this. That is called, it's actually called a rose. That is called a rose. It is one of the classical curves. There are 4 that we are going to study, and the first one is called the rose, the classical curves. Now, it might be hard for you to tell, but if you look at this petal right here in particular, how long is it?
Scaled it had to be in inches.
Look at your graph. How long is this petal? How many steps out is this petal? On your calculator picture, how many steps out is this petal? 2. So for this equation, there are 3 leaves, and they are 2 units long. Okay? All right. Now I want you to go back to y equals, and we're going to change that equation a little bit. Okay? First thing I want you to do is let's just write a whole new equation. Let's do 4 cosine 2 theta. All right, so just type in that. Don't change anything else. Just type in a new equation.
It's a bigger rose.
And now you notice it's still a rose. It's still a rose, but now it has how many leaves?
4.
Now it has 4 leaves. How long are they? Count out the hash marks on your grid. How long are those leaves? 4. So now this one has 4 leaves, and they are 4 units long. All right, so we're trying to keep all this in mind here, because in a minute I'm going to ask you for a generalization. All right, let's try another one. What about 5 cosine, we'll stick with cosine for a minute. 5 cosine 5 theta. Emma?
Is it okay if you have like a box and then another box somewhat like within the flower?
I have no idea why you would have boxes in there. I'll have to look at it. 5 cosine 5 theta. What happened?
Something you can't have.
How many leaves does this one have?
Who said
5 leaves.
Armand can't have it?
And how long are they? 5 units long?
When are you gonna be back in the game? Nothing. When are you gonna be back in the game?
Okay. Well, this is interesting. Are you start? I don't know. I don't know. Let's do one more. Let's do 4 cosine 4 theta. We haven't done that yet, right? Nope. Okay, so 4 cosine 4 theta. How many leaves? 8 leaves. And they're 4 units long? Now, is anybody ready to make any generalization about the equation of the rows, which is R equals some number times cosine and theta? Right? What? Have you made any observations about this number out in front as you look at your different scenarios?
It's always positive.
Well, okay, it's positive. What does it tell you about the picture? The number out in front. So this was a 2.
Petals.
And the petals were 2 units long. And this was a 4, and they're 4 units long. And that one was a 4, and they were 4 units long. And this one was a 5, and they were 5 units long. So if we looked at, which we're not going to because your grid's not big enough, but if we looked at this equation, this would tell me what about my rows?
They're 10 units long.
They're 10 units long. So the leaves are 10 units long. So the number out in front acts like the amplitude. Used to be how high the hills were, but now it's how long the leaves are. Okay, now let's look at this other number. When it was a 3, there were 3 leaves. When it was a 4, there were 8 leaves. When it was a 5, there were 5 leaves, and when it was a 2, there were 4 leaves. Anybody see a relationship there? So even numbers double and odd numbers stay the same. So whatever this number is right here,
That'll be 200.
that's 10 theta. So whatever this number is, if it's odd, that's how many leaves there are. So if it were 7 theta, there'd be 7 leaves. But if it's even, there are twice that many. So this one would have 20 leaves. All right. So now a question you probably have is, what? Yes, you do. You have questions. What difference does it make if it's sine or cosine? So would you go back and put this one back in for me? 4 cosine 2 theta. I want you to take a good look at it, graph it, 4 cosine 2 theta. Take a look at it. And then I want you to change the cosine to a sine. Leave the numbers the same, but change the cosine to a sine. Does it still have 4 leaves, and are they still 4 units long? Yes. What happened? It's not exactly the same picture. What happened to it? It rotated. Now, kids, you remember that when you graphed a sine curve, and then you graphed a cosine curve, weren't they the same curves, just shifted? So what's happening now is they're the same curves, they're just tilted. So all the rules are the same. Okay? So one more. If we had R equals 6 sine 7 theta, how many leaves is it gonna have? 6 sine 7 theta. Without graphing it, how many leaves is it gonna have? 7. And how long are they going to be? 6. This number tells you how long they are. This number tells you how many there are, but be careful. If it's odd, there are that many. If it's even, there are double that many. Okay? All right, I want you to leave everything the same on your calculator. And I want you to type in one more equation.
It's hard to hold up my pockets. Okay.
Would you stop talking? Is that possible? Please? Try real hard.
Yeah.
All right, I would like you to graph this. Don't change anything, just type in a new equation. I want you to type R equals 2 minus 3 cosine theta. Now this is not going to be a rose. This is going to be a different equation.
Whoa.
Now, would you agree that is not a rose, right? You don't see petals and all that stuff. Okay, so let's talk about what we do see. You should see something that looks like this, right? Is that what you see? Now, that shape is called a Lima sign. Now, how in the world are you going to remember, Judah, how are we going to remember that that's a Lima sign? It looks like a what, Armand? A bean. It looks like a lima bean. That's how we're going to remember it. It looks like a lima bean. Okay? Everybody looked at that now? Go back, type in the same equation, but make that a sign. Don't change anything except do sine instead of cosine. Tell me what happens. Change it to a sine. Is it a lima bean still? Yes, but instead of being dented in over here, it's dented in at the bottom, but it's the same shape. Okay? Now, I want you to type in the same equation, but I want this number changed to a 2. And I don't care if you do sine or cosine, it doesn't matter, but make that number a 2.
Just wait for a little thing to come on.
No. No.
All right? What happened?
It got smaller.
Well, it got a little bit smaller, but something more significant happened. The little loop that we had here is now gone, right? Kids, the loop is gone. So what you have, if you did cosine, what you have is a shape that looks like that. That is called a cardioid.
It looks like a heart.
Because it looks like a heart.
Cardio.
Now, cardioids are special Lima signs. You will recognize the equation of a cardioid because these two numbers will match. There will be a test question sometime in your future that says R equals 4 plus 4 sine theta. Is it a cardioid? Yes, because those numbers match. Here we go. We're praying. Full of grace, the Lord is with thee. Blessed art thou among women.